Планета есть колыбель разума, но нельзя вечно жить в колыбели. In these words, a man of progress described the motive for spaceflight. He had written numerous scientific papers, some absurd and others genius. A humble Russian teacher, Konstantin Tsiolkovsky influenced the achievements of the space age and beyond. At age 10, young Konstantin contracted scarlet fever. This left him nearly deaf for the rest of his life and forced him to leave school. Self-taught, Tsiolkovsky took interest in Jules Verne's science fiction and fantasy novels early on, leaving him to look at the skies for the rest of his life. Konstantin's desire to learn pushed his father to send him to Moscow for further studies at a college. Tsiolkovsky attended open lectures from time to time with the use of an ear trumpet, although most of his learning he completed in the library of the Rumantsev Museum. Tsiolkovsky's studies were aided by Nikolai Fedorov, a well-known philosopher who worked in the library. Studying in Moscow lasted for 3 years until Tsiolkovsky was 19. After a couple of years of tutoring and work with physics, in 1876, Konstantin Tsiolkovsky took an exam and qualified for a lowly teaching job in Borovsk, a town near Kaluga, Russia. Subsequent to 1884, Tsiolkovsky began to focus on aeronautics and spaceflight. 2 years later, Tsiolkovsky published an essay on the theory of a full metal dirigible. This idea was very developed, but highly unlikely to be successful due to lacking engineering at the time. The purpose of a full metal dirigible was to prevent airships from spontaneously burning up. At the time, airships were developing quite well and had large potential. In 1894, Tsiolkovsky requested a grant from the Russian Technical Society's Aeronautical Department in order to construct a model. The society turned down Tsiolkovsky's request and declared that the project cannot have any considerable practical importance. One of Tsiolkovsky's friends and supporters, Paul Canning, helped propagate the idea of the full metal dirigible. Due to his initiative, a group of dirigible supporters was formed, which published a leaflet signed by 14 engineers and various well-known scientists and scientific society directors, showing support for Tsiolkovsky's dirigible. The publication of the leaflet in 1904 helped improve Tsiolkovsky's reputation in Kaluga and its surrounding towns. Many skeptics were now enthusiastic about the idea, which motivated Tsiolkovsky. Meanwhile, the disastrous Russo-Japanese War was raging in the Far East. The Russian Navy had trouble moving ships from western Russia to the Pacific Ocean. The only supply line was a one-lane railroad stretching for thousands of kilometers. Tsiolkovsky offered the dirigible project to the Russian government as a solution to this problem, proposing to use the metal dirigibles as a means of transporting supplies. To further influence the government, Tsiolkovsky wrote 2 scientific papers: The Simple Doctrine of the Airship and Its Construction, and Protection of the Aeronaut. In his pamphlet, Protection of the Aeronaut, Tsiolkovsky argued, controlled metallic aerostats of gigantic proportions will be more useful than steamboats and trains. Despite Tsiolkovsky's arguments and a large collection of followers, the government ignored his ideas, even after the war was over. Contrasting to his numerous failures in attracting funding and government interest, Tsiolkovsky successfully brought to life the idea of a wind tunnel. In 1897, Tsiolkovsky constructed the first Russian wind tunnel. The Academy of Sciences in St. Petersburg was interested by this idea and granted Tsiolkovsky money so that he would further develop the wind tunnel. Tsiolkovsky's theories and development of the full metal dirigible and the wind tunnel laid the path for the cosmos. His decade-long work allowed him to understand physics and educate himself further. Soon after the construction of the wind tunnel, Konstantin Tsiolkovsky created the basic rocket equation, which allowed him to realize that the speed of a rocket depends on the amount of exhaust. Later, he would have to revise the equation to account for gravity and drag. In 1903, Tsiolkovsky published the exploration of cosmic space by means of reaction devices. This work is Tsiolkovsky's most famous and most astronomically valued. In this paper, Tsiolkovsky delineated the ideas of stage rockets, airlocks, space stations, and artificial satellites. In order to give the rocket a greater range, a liquid propellant needed to be utilized. Tsiolkovsky's research showed that liquid hydrogen and liquid oxygen were the most efficient propellants. In his research, he compared the best launch position for his rocket, upwards, as the sidewards launch required a larger amount of power. This also allowed him to conceive the optimal shape for a rocket. As a rocket used up fuel, some parts would become unnecessary and would add extra weight to the rocket. This search soon brought him to the idea of stage or step rockets, rockets that would lose mass as they flew on. The initial rocket would be gigantic, as the size would allow for a large supply of fuel, allowing to reach the first cosmic velocity and break the Earth's gravity. Parts that would become empty and unneeded after launch and during flight would break away from the ship, lowering the mass of the rocket and increasing its speed. In 1926, Konstantin Tsiolkovsky created the plan of space exploration, outlining the future of his descendants in 16 steps. First, design of rocket-propelled airplanes with wings. Second, progressively increasing the speeds and altitudes reached with these airplanes. Third, designing of a pure rocket without wings. Fourth, developing the ability to land on the ocean surface by rocket. Fifth, reaching of escape velocity and first flight into space. Sixth, lengthening the rocket flight time into space. Seventh, experimental use of plants to make an artificial atmosphere in spacecraft. Eighth, using of pressurized spacesuits for activity outside spacecraft. Ninth, making of orbital greenhouses for plants. 10th, building of the large orbital habitats around Earth. 11th, using solar radiation to grow food, to heat space squares, and for transport needs throughout the solar system. 12th, colonization of the asteroid belt. 13th, colonization of the entire solar system and beyond. 14th, achievement of individual and social perfection. 15th, overcrowding of the solar system and galaxy colonization. 16th, the sun begins to die and the people remaining in the solar system's population move to other solar systems. Great scientists based their work on his theories and papers. Robert Goddard launched the first liquid-propelled rocket in 1927. Wernher von Braun designed the first rocket to leave the atmosphere and arrive in space in 1944. Mikhail Tikhonravov sent the first artificial satellite, Sputnik 1, into orbit, planning to time the launch with the 100th anniversary of Tsiolkovsky's birthday. Konstantin Tsiolkovsky, an influential scientist, a pioneer of the space age, deserves the commemoration from all people in our world and all future generations.